Hello again. As you know, I am Eli, the computer guy, and today's class is building your own network for a computer lab. So if you're going to start trying to take certification classes, if you're going to start learning how to do some of this higher level technology, you are going to need to build your own network for your computer lab. And it's very important that you do so. So now, in order to build your own network for your own computer lab, you don't have to get its own dedicated internet connection. You can use whatever internet connection you are using now. You can use some of the components of the network you have now. But basically, you have to separate your computer lab network from the rest of the local area network that you have. So whether you're in a small office environment, whether you are at home, whatever you're doing, basically you're separating off your own little lab network so that it does not interfere and cause problems with the larger network. Essentially, all we are doing here is we are creating a DMZ, a demilitarized zone, for a specific purpose. Now, the reason you need to create your own computer lab network is because when you start playing with all of these networking services that you're going to start playing with, those can cause problems for other computers on the network. Or other computers on the network can cause problems for the network that you're trying to build. So this becomes very important once you start getting into the Windows Server world. So I am taping this class right now, right before I start teaching you guys Windows Server 2012. The reason is because in order to make Windows Server 2012 work, you have to turn on DNS and DHCP in the Windows Server 2012 environment. The problem is if you have other DNS or DHCP servers on the exact same network, you try to set up a Windows DNS server, all kinds of problems can happen. You can have problems with client computers getting misconfigured information. You can have problems with the DNS or DHCP servers on the Windows server actually automatically shutting themselves down. It can just cause a complete nightmare. So if you're going to be doing computer labs, if you're going to be doing experiments and all that, you need to separate off your own network so that you can do all this work. Because again, one of the big problems, especially for you guys, is you guys are not skilled enough to know when you are creating a problem or when there is generally a problem with what you're doing. Like once you get skilled, you know whether the issues that you're running into are probably your fault or they're with the software's fault. It's a glitch. When you're new, you don't know whether you did something wrong, you don't know whether it's a glitch, you don't know what's happening. So the more you can separate things off, the better it will be. So let's go over the whiteboard so I can kind of explain to you how this works. But basically, it's pretty simple as long as you follow along. So essentially what we're trying to do is we're trying to create a network for our lab computers, whether they're Windows 7 computers, Windows 2012 servers, whether it's its own Cisco environment, we want to create a network for them. So what we're going to do is we are going to get a router, and we are going to use that router as the demarcation point between our computer lab network and the rest of the network. So we have our lab down here, and this has computers, and it has servers, and it has routers, and it has everything. Well, what we're going to do is we are going to connect everything up in this lab network to the router. Now, under the router, we may have a switch. So we can have a full, complete network under this router. But basically, the separation point is this router. Then what happens is this router will connect to the main router for the ISP, right? So that's the Internet Service Provider. This is the router that connects you off to the Internet. So what happens is you have the ISP modem router. You are then going to connect your lab router to it, and then all of your lab computers are going to be underneath of this. So basically you can have this ISP router here, this can have a switch on it, and this can go to your media center PC, and it can go to your wife's PC, and it can go to your kid's PC, and all these computers will just connect through the ISP's router out onto the internet. Now, because you have this separated off, your lab computers will not affect these. So that's the important reason why we want to be creating this lab network. Because if we start doing experiments and everything is on the same network, you may shut down services that are going to cause problems. Now, the important thing to remember when we're doing a lab network like this is remember what routers do, right? What do routers do? Routers connect separate networks. TCP/IP networks. So it's very important that you remember this when you are setting up the router, because your lab network and the rest of the network cannot have the same subnet. If you have both of these networks have the same subnet, the router won't be able to route because it's supposed to route between different subnets. So what do I mean? So when I normally set up these kind of DMZ networks, what will happen is you have the ISP modem here. Its external IP address will be something wacky, like 208.55.66.4, right? That's the external IP address that goes out to the internet. Inside, though, the internal IP address for it will be like 192.168.1.1, right? That's the internal IP address. So the external IP address and the internal IP address. So anything on the 192.168.1.1 network will get routed out to the internet and off into the cloud, as they say. Well, what's very important then is when you connect this router, the external port for your lab network router has to be on the same network as the internal port for your ISP router. So the external IP address here would be something like 192.168.1.2. So these have to be on the same network so that they can communicate with each other. Basically, the external port for this router is just like a network printer or a network computer or anything else. It has to be on the same network. The important part, though, is that the internal side of this lab network has to be a different subnet. So you can make it, let's say 192.168.2.1, right? Because now it's on a different subnet. So it's very important that you remember this. If this is 192.168.1.1 internally, and it's on the .1 external subnet 2, no routing will happen. It has to be on a different subnet. So that is one of the very important things to remember when you're building these lab networks. So everything has to be on different subnets. And especially, like I'll show you with my little convoluted setup, if you have even deeper routers and networks, everything on your LAN has to be a different subnet. So this would be connected, let's say 192.168.2.2, but then the internal of this third router would have to be something like 192.168.3.1, right? So they're all on different subnets. If you have the same subnet inside your local LAN, all kinds of wacky, nasty, horrible stuff will happen, so don't do it. Remember, they all have to be different subnets. Now, one of the questions you're going to be having, you're going to be saying, well, Eli, but what if I want server services to work on this network? Let's say I have a web server that I want to see if it works right. What if I'm trying to mess around with Windows Server VPN, something like that? Well, if you're going to be doing that, you need to set up port forwarding for the specific ports that are required. I have a different class on port forwarding, so if you don't know what port forwarding is, go take that class. The important part for this lab environment is, let's say your server is down here in your lab, under your lab router, and you're thinking, well, how am I going to get my ports to this server down here? Well, what happens is on your ISP router, you are going to forward the port, let's say port 80, to the external IP address of your lab router. So you're going to forward the port to the external IP address of the lab router, and then within the lab router, you're going to forward that port again to the server. So it's just an additional step. So when you normally do port forwarding, you simply forward the port to the specific IP address it's going to. Well, now we just create a little hop in there. So we hop, we go port 80 gets forwarded to 192.168.1.2. Once it gets into this router, it then forwards port 80 to whatever the server is. So that is how this stuff works. And again, it's very important that you grasp all this, especially once you start setting up, like I say, server Active Directory environments. So let's go back over to my desk again so I can explain a little bit more of this stuff. So basically, we have the internet, right? We have the internet. Then we have the ISP router, then we have your lab router, and then we have whatever else is going on. Again, we are separating out the networks so that communication doesn't mess up with everything. So I want to go over to the computer right now just so I can give you an overview to kind of show you how this looks. So right now I'm sitting just at a Windows 7 computer, and this is connected to my lab network. So my lab network is on the 10.1.10 scheme. So it's 10.1.10, and for the internal IP address of this router, it's 10.1.10. So it's 10.1.10.1. If we scroll down, we can look, and then we will see, so we see the LAN IP for this is 10.1.10.1, and then when we see the WAN IP for this is 10.247.249.122. So this is actually kind of a weird address scheme, but just follow me here. So basically, we can go into that WAN IP, and from here, we can change that setting depending on what you want. Now, since DHCP is set up on the router, that's one level higher than this particular router, I have this set up simply to obtain an IP address automatically. But I could do a static IP address if I wanted to. So this right here is where you set the external IP address of the router for your lab computer. Then above this, we then see our LAN settings, and the LAN settings show that I manually configure this to be 10.1.10.1 with a subnet mask of 255.255.255.0. You can also go and see, and the things like DHCP and DNS, so I have enabled DHCP server on this lab network for the moment, and I have given it a scope of 10.1.10.100 to 10.1.10.149. So if I was going to be setting up Windows Server 2012 DHCP servers on this network, I would come in here and uncheck the Enable DHCP server so that my Windows servers would handle all of that information. So basically, this is the setup for the first router. Then from there, we can go to 10.1.247.249.122, and this is the router that's one level up. So I've actually got 3 routers going on here. It's a little bit of a mess, but hey, that's how it goes. So here we can see that the internal IP address for this particular router is 10.247.249.43. The external, the internet connection for this, the IP address is 192.168.1.10, so that is, again, a different subnet, and the default gateway for this is 192.168.1.1. Now that then goes up to my Verizon router, and that's the main router for the house. So I have the Verizon router. Connected into the Verizon router is my Linksys router. Connected into my Linksys router is my other Linksys router. So basically this is 3 levels, and I have this separated out again just so there's not any kind of nasty weird problems on the network. And as you can see, even though I'm 3 levels down on this network, my internet connection works fine, because this is basically, again, as I say, this is all basic standard networking. So that is really about all there is to building a lab network for yourself. So you already have your internet connection from Comcast or Qwest or Verizon or whoever. You don't need to buy a new internet connection. What you need to do is you need to run a cable from the router that brings in the internet connection to your own lab router, right? So this is what I'm using for my lab. So the cable that comes from your ISP router goes into the WAN, make sure it goes into the WAN connection of your lab network, and then you configure your lab lab router, and then everything in the lab network goes onto the internal side. If you do those things, it's all pretty simple. Now, you don't need any expensive routers to create a lab network. You can go out and you can buy a Linksys router, you know, one of those just wireless routers that they have for 60 bucks at Best Buy, and that will work fine for you. Well, it'll work as well as a $60 Linksys router works for you, but that's all you need. So the big thing to remember here is that you need to create this lab network so other computers on your LAN, your local area network, don't cause problems with what you're doing, and you don't cause problems with them. Make sure that every network, every router is on a different subnet. Remember, routers route between subnets, so if they're on the same subnet, it just really doesn't work right. You can go out, you can just buy a $60 Linksys router or D-Link or whatever you prefer, and the only really complicated part out of all of this is if you want to be hosting services on your lab network that will be accessed from the outside world, you need to do port forwarding. You forward the ports from the ISP's router to the external address of your lab router, and then within your lab router you forward the ports to whatever the server is on your internal network, and that's about all there is to it. This is really a serious thing, again, if you're going to be playing around, especially with the Windows servers. Windows servers really like you to use Windows DNS and Windows DHCP, and if you don't do that, it can cause all kinds of problems. And Windows DNS and Windows DHCP can be really, really finicky, and if it detects other DHCP servers on the network, it can actually turn the Windows DHCP server off, and then it's all kinds of a mess. And I've seen this actually happen a lot in the real world, so be very, 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 very careful with this. So that was a class for you. As you know, I am Eli the Computer Guy. This was building your own network for a computer lab. I enjoyed teaching this class, and look forward to seeing you at the next one.